Hi, my name is Greg Shapland. I'm a technology manager within Orica Digital, and I am the host of the Practical Data Analytics and Machine Learning short course.
My name is Eiman Amini, and I am leading the technical services at Orica Digital Solutions, and I am facilitating the Practical Data Analytics and Machine Learning short course offered by IMM. It is really difficult to eliminate the greenhouse generation or eliminate the impact on the environment with the technology that we have got today. But it is actually possible to reduce that. If we can reduce the amount of energy that we are using to produce a ton of material, a ton of product, then we are reducing our impact on the environment. So basically using this model to reduce our energy consumption, even reduce our water usage, can have a very direct impact on the environment in a very short period of time. Of course, when the technologies are available to reduce it further, then we can look at them as well. And then you also need models to be able to quantify the impact that new technologies would have on the gas emission, greenhouse gas emission rate. So you always need a model to quantify that impact and measure the impact those technologies would have on reducing the greenhouse gases.
To use data analytics, you need a lot of data, and so it's most relevant to existing operations. And as Iman said, it's about efficiency, and not just energy. Water usage is obviously the big one. And where we have new novel technologies that we're working on it, then using the data that we have from labs or plant trials and so forth is really about turning that into action. In terms of harm, not explicitly use of data analytics and machine learning, I kind of suspect that, harm might be in the context of, we've seen in the past where certain parties try and use data to support their vested interests. And so there might be, selective use of data and so forth. I think that, in the course we talk about bias, and some of it being intentional bias and some of it being relatively unintentional. And I think that, data analytics done well, it doesn't really have that issue of harm or bias, because it's part of the process of using that data. You're not selectively using it to try and support an argument. You're doing the approach where you're letting the data essentially speak for itself. There's been a shift in most industries in the last 5 to 8 years in terms of data analytics, where now we have what we'd call data specialists. That didn't exist 8 years ago. And so in the past, you'd have engineers that would go and get some data from a source system, do some analysis in Excel, develop some models, and then make some recommendations and decide to take action. What's really changed from then is that now a lot of the data is stored centrally. It is wrangled by data specialists who produce often reports or analysis, and those intermediaries are the ones that are preparing a lot of the analytics for consumption by engineers. What this course is about is saying, actually, as an engineer, your role is changing, that you don't have to spend the time to go and grab samples of data, that you're actually now needing to understand what is happening between the capture of that data and being produced or fed to them in the form of dashboards or reports. So their role is changing, in that they have to understand that. They have to ask better questions of those people that are preparing these analysis. And then they have to recognize their role in helping people understand what is really happening there. I think everyone in the industry understands the quality of data issues that we often have. They understand that the physics and chemistry, where mining is a physical process. They understand those things, and these are particular aspects of the mining industry that needs to be combined with data skills to make sure that analytics is properly used in mining. So the practicality of what we're doing is not focusing on teaching people skills on programming in terms of using machine learning libraries. It's not necessarily even about manipulating data in some of these tools like Power BI. It's really about focusing them on asking the right questions and also guiding others to make sure that we get the right information and data and it's analysed in the right way, that we can build models that we're confident represent the physical phenomena that exists.
Greg, I would add to that as well by mentioning that there are some decisions that can be taken in an operation that are practical, meaning they are doable considering the time, resources, and the type of equipments that are available at an operation. So basically, looking at the data and communicating with the right people at the operation would allow you to make those practical decisions. For example, we cannot change equipment in a shift or a week, but we can consider expansions in a 2 years' time. So these sort of decisions can be can be analyzed, and based on the practicality of them, the different people from different background can make the decision which ones can be actually adding value to the operation. So those information collected from the data and the models help you to generate set of data that can feed to your analysis and go through those practical solutions and find out which one of them can actually add value and pick the one that adds value most and pursue that.
Yeah, I think just to round that off, we've talked about analytics for its own sake is not valuable. It is ultimately the decisions and outcomes that you derive from that data analytics and machine learning, and that's really the focus.